Okay, so today's lesson, applying exponent properties involving quotients. So 8.1, yesterday we did the product of exponents. And we talked about that if they have the like bases, that you just add the exponents. Well, today they're talking about quotients, so of course that is dividing like bases. So if you have one like this, a to the fifth divided by a cubed. What that means is that you have 5a's divided by 3a's. So you cross out 3, and what do you have left? You have a squared, 2a's left. So how do you get a squared out of a 5 and a 3? Well, yesterday if you were multiplying like bases, multiply, and yes, that is an A. This program doesn't always allow your writing to be the best, so try and bear with me on that one. So you would add the exponents if you were multiplying. So today if we're talking about division, a to the fifth divided by a cubed, that would give you a squared. So you'd have to subtract. Okay? So multiplying like bases, you add them. Dividing like bases, you subtract. All right, example 1. Example 1 has 8 to the 10th divided by 8 to the 4th. Subtract your exponents, 8 to the 6th. B, negative 3 to the 9th power divided by negative 3 to the 3rd power is negative 3 to the 9 minus 3, so negative 3 to the 6th. Now on this one, it is pretty important that you keep them in parentheses, because this, whoops, that's a 3, this completely different answer than this. This means 3 to the 6th power, and you just put a negative sign in front of it. This means negative 3 times negative 3 times negative 3, 6 times. So they are different answers. So if they are in parentheses to begin with, make sure that they stay in parentheses at the end. All right, C has 2 problems in one. You are multiplying like bases, so you add the exponents. That's where the 12 comes from. Divide by 5 to the 7th, so you subtract 5 to the 5th would be your answer. This one, D, just like you are multiplying fractions. So you have x to the 6th over x to the 4th. You're dividing like bases, so subtract your exponents. So you have x squared. So guided practice, number 1, dividing like bases, subtract your exponents, 6 to the 6th. Dividing like bases, subtract your exponents. Again, this is in parentheses, so make sure it stays in parentheses. So I've got negative 4 to the 7th. Number 3, I've got 2 problems in one. I'm multiplying like bases, so I add them. 9 to the 7th over 9 squared. That is a division problem. Subtract your exponents, 9 to the 5th. Number 4, just like multiplying fractions, top times top, y to the 8th, over y to the 5th, division of like bases, subtract the exponents, y to the 3rd power. That would be your answer. All right, let's move on to the next page. Maybe. Okay. Power of a quotient. So this one, a little bit different in that you have this whole thing being taken to a power. Okay, so it kind of builds on what we learned in 8.1. When you take a power to a power, you multiply. You don't see a power here on either one of those, so you assume it's a 1. So you've got a to the 1st to the 4th power, 4 of them. B to the 1st, again, this is also taken to the 4th power, so you have 4 of them. A to the 4th over B to the 4th, those are not like bases, so you can't subtract anymore, so that would be your answer for that one. Let's try example 2. everything here is being cubed. So x is being cubed, y is being cubed. That leaves me that as my answer. B, negative 7 over x, the whole thing is cubed. So that's negative 7. I would just take the negative and just put it right with the numerator. Negative 7 over x. Again, the whole thing is squared. That means that you've got negative 7 squared and you've got x squared. Negative 7, because it's in these parentheses, that means negative 7 times negative 7. That's a 7. Whoops, sorry, and that's the squared part. So negative 7 times negative 7, positive 49. Positive 49 over x squared. Example 3, using all the properties together. So on this one, I've got 4x squared over 5y, everything is cubed. I tell them to almost think like this is a distributive property, okay? So 3 has to go to everything in here, the whole numbers and the variables. So 4 is cubed, x squared is cubed, so I'm raising a power to a power. 5 is cubed, and y is cubed. So 4 cubed, 64. X squared taken to the third power, I multiply them, x to the sixth. 5 cubed, 125. Y cubed is, of course, y cubed. That is my answer. B, a squared over b to the fifth. A squared is taken to the fifth. So that's a to the 10th because I'm taking a power to a power, so I multiply. B to the fifth is b to the fifth. Now, this whole thing is being multiplied by 1 over 2a squared. 1 over 2a squared. Multiply top times top, bottom times bottom, I get a to the 10th over 2a squared, b to the fifth. So out of all this, what I want you to realize is that these right here are like bases. So if those are like bases, I subtract them. So a to the 8th over, there's nothing else to go with these two, so they stay on the bottom. A to the 8th over b to the 5th. All right, let's go to the next page and see what we've got on there. Guided practice, examples 2 and 3. So simplifying those expressions. A is squared and b is squared. A squared over b squared. This one. Negative goes with the 5, and again, keep it in parentheses because it does matter. All of that is cubed. So I've got negative 5 times negative 5 times negative 5, negative 125 over y cubed. 7, x squared to the second power. Multiply, x to the fourth. 4 squared, 16. Y squared is, of course, y squared. So x to the fourth over 16. I don't know why it does that. Sorry about that. X to the fourth over 16y squared. All right, this last one. Lots of different steps that go with it. 2 cubed, 8. S cubed over 3 cubed is 3 times 3 times 3 is not 9. It's 27. T cubed. That is being multiplied by t to the 5th over 16. Now, just when you're multiplying fractions, you can cancel things. So 8, 16, 8 will go into both. This becomes a 2. Come on. Maybe it becomes a 2. There we go. And that becomes a 1. The s's can't cancel with anything. No numbers can cancel here. T's can cancel. If we want to cancel that t cubed out completely, that would make this a 2. And so on the top, I don't have any numbers left. I have an s cubed t squared over 27. There's no letter left here, and there's just a 2, so that would be 27 times 2. So final answer, s cubed t squared over 54. Now, on this last part right here, if you didn't want to cancel all that, you could have just reduced at the end. I could have multiplied everything straight across, and I would have got 8s cubed t to the 5th over 16 times 27. Let's see here. Let's get out the calculator. 16 times 27. $432. T cubed. And then, of course, you would have to divide your numbers, reduce your numbers. 8 over 432 would reduce to 1 over 54. And then you've got s cubed is not going to cancel with anything. But I've got a t to the 5th and a t cubed, so if I'm dividing like bases, I would subtract the exponents. So either way you do it, you would get the same answer. Just depends on which method you prefer.